Hello, and welcome to my presentation on nuclear fusion. Nuclear fusion is the energy that powers our sun, and it can be represented in the equation E equals mc squared. Over here, I have created an example of what will happen inside of a fusion reactor, obviously simplified, to demonstrate how nuclear fusion works and why it's useful. Here we have two elemental hydrogen atoms, tritium and deuterium. We also have a small amount of input energy, which will be used to start the reaction. Let's say the red blocks represented energy. So in here you've got 4 red blocks, you've got 2 on your input energy, and you've got 4 inside your other hydrogen atom. That means you've got a total of 10 energy blocks on that side. On this side, you have also 10 because it must be equal, because energy cannot be created or destroyed. You have a much denser helium atom over here, and because of that, the energy inside, if equal to the energy in one of the other atoms, therefore you've got 4 plus 6, you have 6 output energy. This will produce 1 dense atom and extra energy that's released from within the hydrogen atoms. It's mechanically efficient because you start with 2 input energy blocks right there, and by the end you have 6 energy blocks. Therefore you've tripled your energy. Now of course these aren't exact numbers, and this is just a very simple example. However, on a much larger scale, thousands and thousands of hydrogen atoms will undergo this reaction and become helium. Now it's mechanically efficient because we get more energy out than we put in. However, that's very difficult to do right now, and up until very recently in Germany and China, this was not possible. The German reactor, for the first time, for 1 second, sustained a fusion reaction at 3 million degrees Celsius. It was contained within super powerful ring magnets, which controlled the fusion reaction inside. In here you can see a small ball of plasma, and that's what the fusion reaction basically looks like. It must be contained by magnets because no metal that we have, or any element for that matter, is tough enough to withstand 3 million degrees. Then, the energy that's released from fusion, as we showed over here, is used to boil water and turn a steam turbine, just as conventional methods have for a very long time. Now, I haven't got any examples for this next part, so I'm just going to stand out in this field over here. So, commercially viable, yes, it is commercially viable, or it will be in the future. It has very, very, very little fuel cost, and this is thanks to the fact that hydrogen is the fuel, and hydrogen is the most abundant element in our universe. Helium is produced from this, and therefore can be sold afterwards to recoup some of the cost of buying the hydrogen, which will make it in turn cheaper for the power manufacturers and also for the consumer. Governments have been funding fusion because many private companies are already funding other sources of renewable energy, such as wind and solar. It will not be as cheap initially, however, because many companies will be attempting to recoup their research and development costs, which have been under development since 1980. There's a reactor, ITER, which was planned in 2007 and is still being worked on today. It's currently valued at 5 billion euros and generates 500 megawatts, or will generate 500 megawatts once it's completed. This is a very good example of a standard reactor that would become useful in the future. It will be cheap. It won't be cheap as it starts. However, once becoming more commercially viable after research and development costs have gone down, nuclear reactors of this variety, fusion reactors, will become much cheaper. This is because fossil fuels will be becoming much, much, much more expensive because, of course, we're running out of oil and we're running out of coal because we're burning it so much faster than it's being generated. However, we can generate so much hydrogen that will never run out. And the fact that these reactors run off hydrogen will make them very, very, very cheap and inexpensive options in the future. However, until then, we must still use fossil fuels in order to generate our energy. Now, the environmental concerns, there aren't many. Really, if you look at a standard fission reactor, all right? So fission reactors developed a long time ago, and are based on older technology. Two very, very dense atoms are smashed together to become less dense atoms, and this generates a small amount of energy compared to fusion. However, there are many problems with these for the environment, one of which is, of course, the famous meltdown reaction, which is seen in Fukushima and also in Chernobyl, which leaves radioactive waste which is harmful to almost anything, and also will leave a crater behind in the place of the nuclear reactor. Also, we also have much radioactive waste that we have to deal with that comes from running these reactors. This is buried in landfills and must be dealt with accordingly. But really, we just dump it in the ocean or in a landfill somewhere, and that's not very good for the environment either. Fusion, on the other hand, is very simple. If you have a fusion reactor and it melts down, or melts down, quote unquote, if something malfunctions inside of it, all that will happen is the reactor will ignite, and then it'll go off. The plasma will leave, and the reactor will stop. However, in the event, of course, of a nuclear fusion reaction, or a fission reaction, rather, bad things will happen, the reactor could explode, etc., etc. We all know how that goes. Now, location-wise, reactors will probably still remain located out of cities for the near future. However, in the far away future, it is possible that nuclear reactors will be put inside of cities, or perhaps even inside of military vehicles first, just as the first nuclear submarines were invented. Now, there are very, very, very few cons. In fact, only one that I could think of to nuclear fusion, and that is it's an unlimited, cheap energy source. And you might think, oh, that's not bad, right? Well, it would be in our case because we're human. We're very, very likely to do something not so great with it, like destroy other planet or some other planets or something, because we just can. And having that much energy could cause us to do things like that. Now, versus renewable resources, everyone says, oh, well, solar energy and wind energy, that's the way of the future. Now, the issue with solar and wind energy is they take up a lot of space. Solar and wind energy take up so much space, in fact, that in 9.5 square miles, 500 megawatts can be achieved, and in less than a tenth of that space, so can nuclear fusion. However, until the day we can achieve that and create that much energy from nuclear fusion, we'll have to wait and depend on solar energy for the time being. There are very few cons to nuclear fusion, as I've gone over before. So please, if you've got to vote for it, vote for nuclear fusion over solar energy any day. And thank you for listening to my presentation.